Hey guys, let's start today's weekly contest of Leetcode. This is 484. Let's start with the first problem. The problem says you're given a string S consisting of only lowercase English letters. The prefix of S is called residue if the number of distinct characters in the prefix is equal to length modulo 3. So what this problem says is uh, suppose give a particular string A, B, C, D, E, F, dot, dot, dot. So for every index, suppose we are the index this, the number of unique characters, suppose the unique characters here is suppose x, this should be equal to whatever the particular length till this index. So as we follow zero based indexing, so what is the length till index number 2? This is basically I plus 1, right? So it basically tells if this x is equal to this I plus 1 modulo 3. That's the simple thing that this question tells us. And how we can get this x? So while traversing in this string, right, what we can do is we can put every number in every character in a set. So set contains only unique characters, so we will put set this A, this B, this C. Then whenever suppose this particular character is C itself, okay, then while we are maintaining a set, we first put A, then we will put C. Then again when we are putting C, this C got replaced in the set, so we don't include another C here. So that's the property of set, right? So till this step, till the index 2, we got this in the set, which is basically 2. So particular 2, is it equal to I is 2 here, right? We are going to index 2. 2 plus 1 mod 3, which is basically 3 mod 3 is 0. Is 2 equal to 0? No. We don't get any answer. So the first question is as simple as this. We just simply put every every character one by one into the set. And while putting in the set, for every index, we will check this condition, right? Let's go into the code. So this is as simple. We are maintaining a set here, and then we are keeping an answer. And while traversing in the array, in the string, we put particular character, this s of I, into our set, and then we also check if that is equal to this. If yes, if this condition gives us a true, then we will increment our answer. And finally, we are returning the answer. So let's submit this. That got accepted. Let's move on to the next question. So what it tells is you are given integer array nums. Subarray of nums is called centered if the sum of all its element is equal to at least one element. So what it tells is actually if we are having suppose numbers 1, 2, 3, 4, 5, 3. Okay. If suppose we pick any particular subarray, suppose this, okay, and we take this sum. If that particular sum is equal to some particular element, if suppose it is equal to this or this, then we got one answer. Here it is not equal. Suppose let's take a different example like this: 1, 2, minus 1, 5, 6, dot dot dot. So this is a particular array. Okay. Now, when we talk about this particular subarray, right? This particular subarray, what is the sum? 1 plus minus 1 plus 2. That's 2. And this 2 is equal to actually this 2. Right? So the sum actually lies in a particular this subarray. So we got our answer here. And the easiest part about this problem is the length is only 500. So we can loop through it twice, right? Let's just check the solution. We're taking this size of the array, we're taking answer, then we traverse from 0 to ending of the array. Okay. We're maintaining a set to store the element so that we can check while performing the sum for this subarray. We can check whatever the sum we have. Did we encounter that sum previously? Suppose we take this one, we take this two, okay, then we take this minus one, and the sum is two. Then in the set we have this three elements, right? In the check set, if we check if the particular sum is exist, yes, it is two, right? So we simply return. So that's why we taking the set. We're taking a sum while traversing in the loop from I to n. We take the sum, we check if the particular sum is already in the set. If it is, right, this particular count says how many occurrences of there in this set for the sum. If there is an occurrence, that means occurrence is greater than 0, then we got one occurrence for that particular subarray, right? So in that way, we can increment our answer, finally returning. Let's submit this. This is accepted, right? So 2 problems were down out of 4. Let's move on to the next problem. Let's see what this problem says. It says you are given an array of words of n strings, and each string has a length of m, and it only contains lowercase English letters, and two strings s and t are similar if we can apply the following operation any number of times, right? So we'll choose two strings. So how we can tell that if a particular two strings are similar? We'll be taking two strings, then replace every character in the chosen string with the next character in alphabet cyclically. What it tells is, let's see with an example, right? Let's take this as an example. Copy this. Paste. It didn't got paste. Oh, okay. Let me just draw this. So the first string is fusion, and the next one is layout, right? So what it tells is we can pick one string, pick any of them, and we can rotate it cyclically. What it tells is, suppose we have a string ABC. Okay. If we rotate it cyclically once, then what it becomes is B, C, D. We increment every character by one. So what is the next of A? It's B, right? What is the next of B? It's C. Next of C is D, right? So in that way, we can cyclically move. So between these two strings, if we can cyclically move one string, and then so as we can see that we got B, again we got C, D, E. In that way, we can get X, Y, and Z at one place, right? What is the very next of this? Is Y, Z, A. The next of Z is A. The next of this is Z, A, and B, right? And what is the next of this? This is basically A, B, and C. As you can see, this is a complete cycle. We'll move like this. So we need to tell if we move for this like this cycle, we move to fusion to some. And if between this path we got this layout, then we got an answer. Similarly, if we can move for layout also, and if between this part we got this, because if they are same, then in this they lies on the same cycle, right? Suppose the fusion is at this stage, some shift is giving us answer of this layout, right? Both of them lies in the same cycle. So how we can solve this optimally? So having every cycle for this one is not very optimal, right? How we can simplify this? As I told you that this particular fusion makes a cycle if we follow cycle order, right? So what if we trim it down to the very base cycle? As this suppose fusion is at this place, layout is at this place, okay? What if we bring layout to this place and fusion to this place? Basically we are normalizing both of them. Base should be equal, right? So the normalized string of both of them should be equal because they lie in the same cycle. How we can do that? Just let's just pick the first character, right? This is the first. So f lies in which place? So f is basically, if we consider a, b, c, d, e, f, it's on the sixth place, right? So what we do is we minus 6 from each of them. Okay, we'll minus 6 from each of them. So that will makes it 0. 6 minus 6 is 0. Similarly, we got some number here, number here, number here. Similarly, we'll pick the first character. That's L. Suppose, what is the L's number? E, F, G, H, I, J, K, L. 6, 7, 8, 9, 10, 11, 12. It's on 12, right? L is on 12. So what if we again follow the same logic, right? This L becomes 0. Then, as we assume that this is equal, if that's equal, then this should follow the same, right? And finally, we try to match this. If this base normalized string is equal, then we should get this as answer, right? So how we are normalizing is the key thing here, because the first string, the first character, we tend to give it 0. Here also, the first character we tend to give it 0. If the first character is giving to 0 with this much of shift, here shift is 12, every particular number should be shifted down 12, right? Here every particular number should be shifted down by 6. That means if from the base string we go 6 step, we got the fusion. Fusion is here. If we go the 12 step, we got the layout, right? That's the answer. So let's go into the code. So we are maintaining a map. Okay, we go to every words of this particular array, and then we are making the normalized string this s. We take the shift, whatever the shift we have done from the first character. Then what we will do is we will go into the string, the particular string. Suppose this fusion here. Okay. So what we will do here is we will make our normalized string. That is the particular character converted into number. Then we will minus the shift to make it 0 for the first character. Like here we are minusing 6, right? That's the same thing. And this particular plus 26 is basically to deal with negative numbers. Let me give an example. Suppose we have f, then in a dot dot dot. Okay. F is on 6. This a is on the first, right? When we do a minus 6, this basically becomes a negative number. So as we are taking a as 1, b is 2, dot dot says 25, 26. So we should not deal with a minus number. So we just increment it by 26, right? So that it becomes cyclic, becomes 21, because the very previous of a is z, previous of z is y, previous of y is x. So if we make it 21, that's 26, 24, 25, 24, W, V, U, 24, 23, 22, 21. It becomes U. So in order to handle these negative cases for the cyclic one, we increment it by 26 and then modulo 26 to make it a cycle, right? Then for this particular normalized string, we'll check how many occurrences of it is already there in the map. That many times we can club this up, right? Let's see this. Suppose in a map, suppose for the fusion, we are at the fusion, right? We got a layout earlier in this array, dot dot dot. So for this layout, and suppose there is one more string that is equal to layout, okay? So that normalized string S would have already two occurrences. Now we are at fusion. So again for the fusion, we got the normalized string as S, right? So we'll check how many occurrences of S already we got in a particular map. It says two. Suppose that's a string A and string layout. Okay. Then this particular fusions can be paired with this particular A also, this particular layout also. So this layout can be paired with S means fusion, and this particular A string, suppose that's another string that's has the same normalized string, right? So this particular A string also can be clubbed with fusion. So we will increment for this fusion. We got how many occurrences? We already got this many of this. So in the answer, we'll increment it by 2 because we can pair it with how many occurrences we already got. Right. After that, we will increment for this particular kind of fusion, and then we finally return the answer. Let's submit this. Yeah, that's correct. Okay, so let's move it to the final problem. So this one is bit tricky problem. This is. Let's just try to understand this. Okay. So the problem says you are given an integer array nums and two integers k and m. So we must perform at most k operations, and in one operation what we can do is we can increase a particular element by 1, right? And we need to return an integer denoting the maximum possible bitwise end of any subset of m. Okay, so suppose let's see this example. It tells there is a area of 312 and we have k is 8. We can at most do 8 operations, and we need to find out after doing this much operations how many of them can be done with this is the subarray, and how many of them can have the maximum uh, value. So that maximum value we should return. So we need a subarray of size m equal to 2, right? So we will choose this particular index 0 and 2 subset. Remember, this is not a subarray, this is subset. Increase the nums of 0 by 3 because we can do the increment step 8 times max. So now this 3 becomes 6, and we increment this 2 to 6 using the remaining 4 operations. We already have one operation left. Okay, so we are dealing with 7 operations till now. Increment this 3 to 6, this 2 to 6. Now we got subarray as 6 6, and the bitwise end is 6, which is the maximum possible. Okay. Let's understand this with code itself, right? It's a bit trickier. If we try to understand it carefully, then it's easy. So what it does is we take the answer, we take the size. So we will think bitwise. Think bitwise. How think bitwise help? So we need to give the maximum bitwise end. So we are more concerned about the leftmost bit. Let me tell you. Suppose this is the particular binary representation of our answer. Having the leftmost bit set will make our answer as much increase bigger as possible, because this is, suppose this is at position 3, not 3, suppose this is at position 10. This particular bit contributes 2 to the power n to our answer. So having a bit set from the left side would always benefit us, right? So we will move it from I equal to 30 till 0. We will try to make this bit set in a particular answer. While try to making this bit set, we will check in this whole array. If we try to make this bit set, then how many of them already has it set, or how much it is cost. Suppose this bit is set, okay, and we got a number which is like this bit is not set, so we need to make it set, right? So we need to make it 1. So that will tell me that if I can make change particular number to this number, then we can have this bit set, right? You got it? Like this bit is set, so this particular number is this. Let's do it below. Suppose our answer is this, okay, and particular array, one of the character is this one, 10. So we are at currently this position. We need to, in order to make it set right here, we need to make this particular number to this particular number, right? This is the nearest number that is having this particular bit set. So in order to do this, we need to have 100 minus 10, which is in binary. We will convert it to decimal. This is 4, this is 2. So we need an increment of 2. So this is the cost in order to make this particular number having a bit set with this, right? I think this is understandable. Now, suppose the answer is like this. This bit is set, this is not set, this is set 0, 0. Now, suppose this one is not there. Now, suppose a particular number in the array is this 10 again, and it has 100. So this is the number, okay. It already has this bit set. This is as it is, but it doesn't have the display. So from the very left, it doesn't have this bit. This one. This one. So how this will deal is we will calculate the cost. Let's see. We will keep the first part and make everything on the right 0. Okay. How we can do this? We can basically have a this thing 0, 0. We can have 1, 1, 1. Then we can just invert it. We can have this number, right? We have this bit minus number, 2 to the power bit numbers minus number is this one, and we can invert it to get this thing. And if we take a AND with this, the answer, this is the answer. If we take a AND, then we can get whatever the previous part prefix that we need to set in order to make this number having all the set bits as this particular answer, right? This particular 3 bits we are concerned about. So we make all the 3 bits 1 here, all the remaining bits 1 here by looking at this formula, 2 to the power bit minus 1. Then we will invert it by using this keyword inversion. Then we will take a AND to get the particular bits as set as this particular answer. Now we got to know that we need to achieve this. We have this number. The difference between them would be the cost, right? So how we will calculate the answer is basically we will try to make every bit set. We'll look through the array. We'll calculate cost of each of them, the cost and the minimum possible costs, the costs of the lowest m, because we are concerned about m subsets. Lowest m numbers, if that particular cost, total cost, is less than equal to k, and we are getting the answer, right? We can take this particular bit in our answer. Then we will move forward with checking for this bit, similarly this bit, similarly this bit. Suppose between this, for this bit we don't, this condition doesn't satisfy it, then we don't update it, right? In the final answer, this bit is set, this is not set, so that's not an issue. Okay, let's move on to the code. So here we're going from the very leftmost bit, we're taking this bit's number as target. So this answer now currently have all the set bits still now in the answer with current bit try to having set. Okay. We will put every cost in this particular array. For every number we will calling this particular function, we will look it later, and we try to make it equal to the target, and for the cost we will sorting them. Then after that we will loop the first m lowest costs that we have, making it to target. Then if that's less than equal to k, our budget, then we can make this particular target, right? Then we will try to increment our target by setting the next bit. If we are having it till this bit, then the next thing we can do is try setting this bit. The answer would definitely increment by setting more bits here and here, right? Let's see the get cost. So if that particular numbers and is already target, that means this particular number already had all the bits set as same as target, so we don't need any cost here. Now we are finding the conflicting bit here, so we will traverse from very left in the target, and we take the bit, take out the bit, we take out the bit in our particular number. If target bit is 1 and nums bit is 0, that means there is a conflicting bit, right? Here we told that this way. Suppose the target bit is like this, okay, and the number is like this. This is the target. This is a particular number which we are checking. Okay, so we will move. This bit is okay. This bit is okay. This bit is okay. Okay. When we got this bit is set and this bit is not, that means we need to make this number increment to the point that it matches all the things like this. How we can do that? Let's see this. So we will make every number of this particular number. How we can do this is we will only keep these numbers. Let's see this. For this number we will make it like this. We will set this particular bit and we will keep as it is bits like this left part. Okay, now after that we will just know that we need to make it equal to this. We'll just take the difference. How we will make this from this bit? Already told, right? Let me just told it again. We'll make, this is the conflicting bit, right? So we'll make every bit till here is 1. So 2 to the power this particular conflicting bit minus 1 is basically makes it like this. Okay, after that it will make it like this. After that, we will inverse this 1110000. We'll make it like this, and then we will take the end with this particular target, which is 101010000. Then we'll finally get whatever the prefix is end 01010000. Yeah, whatever the prefix we want to match, right? Let's see this in the code. So we got the conflicting bit. We'll taking this new number to which we are able to increment this particular number. This particular mask is basically this conflicting bit plus 1, 2 to the power conflicting bit plus 1 minus 1 is what I already told in this example. And then we are taking the negation, this step, and then we are taking AND with the target. This is AND with the particular number. So this basically means that if we take the AND with the particular number, what the number already has. Let's say this. You already got this step. If we take AND with this number, it's basically becomes, it already has whatever the bits we already have in this number. So we need to take out of this, right? This bit is already set. We don't need to make our cost making this bit set also. So we are taking this as it is like this, and then we will make it set, right? After that, we'll try to have every bit from this particular target by having an OR. We can see that we'll take the first portion with all the set bits as the previous number. Then we will make the conflicting bit set. After that, we are making sure every preceding bits were also set like the target. Finally, the difference is the cost, right? This problem seems to be a bit trickier, but if we focus it more and watch the video twice, you can definitely get it. So yeah, all these 4 questions were done. Happy to meet you in the next stream. Thanks.